Now I continue to explain this problem. In the last video, I explained this problem with dynamic programs thinking. And for this problem, and it has a more efficiency problem because the DP solution has a time complexity O(n) square, and I want to reduce the time complexity to O(n) log n. So for I say the log n, and I need to consider the binary search. Binary search is similar to binary search method, and I will try it. I will first explain it. So explain for this one, and the basic idea is I will keep a increasing subsequence. For this one, subsequence, and let's assume I have get a subsequence in the previous operation, and like this, and that is currently the longest increasing sequence subsequence, and right now I visit current element is 6. So for this 6, it cannot change the subsequence less. But consider if I use if I found this current subsequence the first the greatest the least element greater and equal than 6, I found the 9. So for 9, and if I use 6 instead of 9, and for this subsequence, it will better for the later subsequence. For example, and if I visit the next element is 7, right now the 7 can be can generate the right now the 7 will be also, and right now 7 can also continue to instead 10. And if currently I visit is 8, the 8, 6, 7, 8 with the previous 1, 2 can generate a new longest increasing subsequence. So if I don't instead of the 9, 10, and I cannot easily to track the longest increase subsequence. That means if I encounter if I found an element can instead of this the least element greater and then this element greater and equals than the element, and I can instead of it because this element can reduce the level for the subsequence, and it's better for the later visit. So the basic idea is like this. So we will keep the subsequence, use a data structure Treeset. Treeset found the insert operation, and insert elements can reduce the log n time complexity, and until I will find finally I will check this subsequence size. So first I need to use the Treeset data structure to maintain the current increasing subsequence. And when I encounter this Treeset, when I encounter one element, and if I found any number more than this element, and I can use this less the element to instead of it. And if I cannot find it, that means this element is the largest element for the current subsequence, and I can directly add it into the chat. And lastly, I can directly return this set size. So the basic idea is clear, and I will try implement it, and I will define a Treeset. Treesets. Don't forget the corner case. Don't forget the corner case. Right now, I need the out loop. Out loop is traverses this array. And I will check the Treeset if the set ceiling flow ceiling lower bound ceiling the numbers. I found any element more than this current element. Else if I can insert, replace it, ceiling that will be finish the element can be removed and then return it. Set remove ceiling set. Into current. Not now. That means I found it, and I will remove the element and use this current element add status. Cannot find it. Set size. When I traverse the finish, and the current set is the longest increasing subsequence. So the basic idea is also a explain, like a previous explain, and when the current is 9 type, and if I add a new element, this element is less than 9, and I can use the 6 to replace the 9 because the 9 1 to 6 is a lower level subsequence, increasing subsequence. It benefits to add more suitable element like this one. So when I replace with 6 and 7 to instead of 9 and 10, and when I visit the 8, and I can use the current set to instead of to add the 8 to generate a new longest increasing subsequence if I cannot instead of it and 1 to compare the subsequence, and the subsequence will be 8. 8 is cannot generate a new longest subsequence, longest increasing subsequence. So the speed is from 10 millisecond reduce 3 millisecond. So that is from the ON square to reduce the ON log n. So hope that is helpful for C++, and the data structure is also vector, and the lower bound function can solve this problem. I will stop it and I hope it's helpful.